So in this video we're going to learn or refresh your memory, either way, about how to sketch some absolute value graphs. Okay, so we're going to do that by finding the zeros of the function, and then we're going to use those zeros to help graph some stuff. Okay, so basically absolute value graphs are always linear equations, and they always graph to a V. Okay, so if anytime you're going to have a graph, they're always going to graph to a V, and the slope going in is going to be the exact opposite as the slope coming out. Okay, so there's some things to know. This is of course called your vertex. It's a pretty important part. Here we have the zeros or the X-intercepts, and then we have the Y-intercepts. So we'll use all of those things to help sketch our graph. So here we have the function f of x equals the absolute value of x plus 2. Okay, so the first thing we're going to do is find the X-intercept. So for the X-intercept, we're going to plug in 0 for y. Okay, so 0 equals the absolute value of x plus 2. Okay, so in other words, 0 equals some number plus 2. So subtracting 2 from both sides, x is negative 2. Okay, which means it crosses your x-axis at the point negative 2 comma 0. Right, so the x value is negative 2 when y is 0. That's the point negative 2 comma 0. Okay, the next thing we're going to do is find the y-intercept. So that means at the y-intercept, the x value is 0. So y equals 0 plus 2 in absolute value, so y is simply 2. So that's the point over here, 0 comma positive 2. Just like that. Okay, now the rest of the points we can figure out by making a t-table of x and y values, so x and y. So let's see what happens to the left of negative 2. Let's plug in negative 3. So negative 3 means we have the absolute value of negative 3 plus 2, which is the absolute value of negative 1, which is going to be positive 1. So when x is negative 3, y is positive 1. Okay, so it looks to me, since we can take some clues here, right? It says the slope of my lines going in and out is just going to be 1. 1x plus 2, so the slope of this linear line is 1. So we can basically figure out that this is going to be the graph of your absolute value equation. Right, that has a slope of 1. It happens to be negative 1 because it's coming from left to right. And then it's going to turn around, and here's a slope of positive 1 going out this direction. Okay, so we use some clues from your given function. Right, this is the slope, this is the y-intercept. We just have to figure out where this graph turns around and starts going back up. Okay, and in this case it happens right here at the point negative 2 comma 0. So this is your vertex. This has a positive slope going up this way, and this has a negative slope going up that way. Okay, so those things come from your clues. Let's look at another one real quick, a little bit more complicated one. Here we have an absolute value of 2x plus 6 minus 4. Okay, so let's put some points on here. Once again, let's find the x-intercepts. So remember, for the x-intercept, that's when y is 0. So we set 0 equal to the absolute value of 2x plus 6 minus 4. Okay, and now we solve this equation for x. So 4 equals 2x plus 6, and so on and so forth. We split this into two equations. And we find out that x is negative 1 and x equals negative 5 are the solutions to this equation. So that's where this graph crosses your y, or rather your x-axis, okay, when y is 0 on the x-axis. So we can come over here and we can put dots where x is negative 5 and x is negative 1. Okay, so those are your intercepts. That's where it crosses your y-axis. That's where y is 0, negative 1 and positive negative 5. Okay, there's a video about how to solve these up there too, so if you forgot, go back and watch it. So now let's figure out where it crosses your y-intercept, your y-axis. So the y-intercept is where x is 0. So in other words, y equals 2 times 0 plus 6 in absolute value minus 4. Okay, so that gives me a 0 plus 6 minus 4. which is the absolute value of this is positive 6 minus 4, which is positive 2. So the y-intercept is here at positive 2. Okay, which is kind of what you would expect. Okay, looking at this graph, we have a 2x, right, in your absolute value. So that's going to be the slope of your lines. Your lines are going to have a slope of 2x, which is great because that's what this slope is, right? Up 2, right 1, up 2, right 1. We can get more points by continuing on with this slope pattern, up 2, right 1. But also down 2, left 1, down 2, left 1. Okay, down 2, left 1. But it also has to happen from this point. Remember, this point over here, negative 5, is also one of your intercepts. So in other words, it's going to happen right in the middle. If these are your two intercepts, then your vertex is going to be right down the middle, because absolute values have an amazing symmetry, just like quadratics do. So we can erase this point because this point is not going to actually be there. Okay, this point right here then, I'll make this green. This point becomes your vertex. Okay, this is where the graph switches and turns around and goes back up. So on the left side then of this line, we're going up 2, left 1, up 2, left 1, and we get all these other nice points from your graph. Okay, so this comes from evaluating your given function. 2x plus 6, so 2x is your slope. So we have a positive 2 slope from the right of your vertex, and we have a negative 2 slope to the left of your vertex. Okay, so there are some clues about what it looks like given to you within the functional problem itself. So here are your x-intercepts at negative 5 and negative 1. We come over here, you find your y-intercept at positive 2, which allows us to find the vertex. Okay, we get down to the middle of these 2 points, and that's where you find your vertex right there. Okay, so hopefully that's a quick refresher or a little lesson about how you find or how you sketch the graph of an absolute value. They're always V's, so you always have a negative side and a positive side, and they're always linear equations on both sides.